There are solutions to perfect problem 6 for Math 112. What we're basically trying to do is come up with the law of cosines and then use the law of cosines. Okay, so first what we want to do is express the length of the height of the triangle, so this guy right here, in terms of a trig function in angle C. So this is angle C right here. The only other, if you look at this right triangle right here, the only other side I know is this guy. So if I want to know the side opposite this angle, and I know the hypotenuse, what I can do is say that, where do I write this down here maybe? That the sine of angle C is equal to, this is opposite over hypotenuse. The opposite is the height, and the hypotenuse is B. In other words, the height is equal to B times the sine of C. So this H right here is equal to B sine C. Alright, so there's number 1. Number 2, express the length of the side between C and D, this thing right here. Same thing in terms of angle C. Well, let's see, I know that this is what I can use cosine. I know that the cosine of C would be equal to this, what should I call this, like x maybe? Guess I'm not using x anywhere else. Maybe I need a little bit more room there. We'll call this length x, and I can say that the cosine is adjacent over hypotenuse, so that's x over b. In other words, x is equal to b cosine of C. Alright, that's the end of 2. Number 3, express the length of the side between B and D, this thing right here, in terms of length A. So A is the total length, and this guy I just found. So what we can do there is, this side is, it's not A is the whole way, but it's A minus this thing. In other words, it's A minus B cosine of C. I guess I could write that down here. I don't really know what to write other than A minus B cosine of C. Sure. And then in step 4, when I finally start doing some algebra, it says use Pythagorean's theorem on triangle ABD. So what I have right here is a triangle, a right triangle. So a squared plus b squared equals c squared. The sum of the squares of the lengths of the two sides of the legs, it's got to be equal to the square of the length of the hypotenuse. In other words, b sine of C squared plus a minus b cosine of C squared, a squared plus b squared has got to be equal to c squared. And then number 5 says expand this thing. So I can do that. It's time to switch colors. So basically what number 5 is saying is square all this stuff. Go ahead and do it. This first one, I guess I could write that as b squared times sine of c squared, which we write like this, sine squared of c. And then this one, if I FOIL this all out, I'd get an a squared. I'd get minus 2 of these ab cosine c. And then I'd get this b cosine of c thing squared. I'd get b squared cosine squared of c. So if you take this and expand it all out, kind of square everything that it says to square, you get something that looks like this. And then 6 says factor out a b squared from the 2 terms in your equation. So it's saying that there should be 2 terms here that have a b squared in them. And I believe there are. We got b squared in this first term, and then we got a b squared in this last term, third term, and then I still got this a squared, and I still got, I guess that was the fourth term there, and I still got this term ab cosine of c. So all I did so far is I rewrote this in a different order so that the terms with b squareds next to them are next to each other, because then it's easier to see what happens when I factor out a b squared. I get sine squared of c left in the first term and cosine squared of c left in the second term. Then I can leave all this mess alone. And the reason you might want to do this is in 7, oh no, we're still in 6, it says simplify using the above Pythagorean identity. What? We have this Pythagorean identity up here that says for any angle, sine squared of that angle plus cosine of that angle equals 1. So for this angle C, sine squared plus cosine squared has to be equal to 1. All this stuff in here is equal to 1. This stuff that I've underlined here just equals 1. So really I can say b squared times 1 plus a squared minus 2ab cosine of c equals c squared. Or typically the way you write it is a squared plus b squared, so it looks more like the Pythagorean theorem, minus 2ab cosine of c equals c squared. Either of these are fine. I wrote this one first just because that's the way you typically see what is called the law of cosines. That's what they're saying is what I've come up with here. Wow, I'm going to be pretty low on room here. What number 8 says is, this is one law of cosines here, law of cosines. But there's 2 more you can come up with if you just, instead of starting with this triangle, A up here, B over here, C over here, maybe I put A here and B here and C here, or kind of switch things around. And what that will give you is 2 more versions of this formula that are very similar. B squared plus C squared minus 2BC cosine of A is equal to A squared, or C squared plus A squared minus 2CA cosine of B is equal to B squared. So there's 3 versions of the law of cosines. I don't know. I feel like I should put a box around those or something. But with those 3 versions of the law of cosines, we can then go and answer these questions. So I'll jump back up here. I'll write small because I'm very low on room. In 9a, I know that A is equal to 5, B is equal to 6, and C is equal to 8. So if I use this version of the law of cosines, you could use any of these, I suppose, in this first one, but I'll use this first one. I get that A squared, 5 squared, plus B squared, which is 6 squared, minus 2AB, 2 times 5 times 6 is 60, cosine of C is equal to C squared. And if you solve this, if you move some pieces around, 5 squared is 25, and 6 squared is 36. So we get 25 plus 36 is 61, and this is 64 over here. So I can get negative 60 cosine, I guess I should write it out. 61 minus 60 cosine of C is equal to 64. So negative 60 cosine of C is equal to 3. So the cosine of C is equal to 3 divided by negative 60. In other words, negative 1/20th. So C is equal to, let's see if I use my calculator here, make sure that you're in degree mode, and then all I want to know is arc cosine of negative 1/20th, negative 0.05, and you can get that on your calculator by using second and then cosine, second and then cosine, and then we want negative 0.05. And what that tells me is that C is approximately 92 point, how many decimals do you want? 1? Sure, 92.9 degrees. Okay, so this is C is 92.9 degrees, and now we can figure out what another side is. Maybe we could figure out A by saying that the sine of A divided by 5 is equal to the sine of C divided by C, and C was equal to 8. So what I get is that sine of A is equal to 5 sine of that mess that I just came up with divided by 8. So, well, let's figure out what that is. If I do that answer times 5 divided by 8, I get this mess. And then if I, oh, that's not what I wanted to do. Shoot. Okay, so I wanted, pull back a couple entries. I wanted arc cosine of this. I want to know what's the sine of that thing. So sine of the answer. And now that I know the sine, I can multiply that by 5 and divide that by 8. And what I get is that the sine of A is equal to 0.624 or whatever. And so I can do arc sine of that. And that will tell me that A is equal to about 38.6 degrees. And now that you know A and C, you can figure out B by saying that 92.9 plus 38.6 plus B has got to be 180. If you add up all the angles of a triangle, it's got to be 180. So if I do 180 minus, I guess I'll use my rounded versions, 38.6 minus 92.9, what I'll get is that B is equal to 48.5. All right, somewhere in here I'm supposed to squeeze in all this again. I guess I can do that. I don't know where exactly. Maybe I can switch colors. Let's go back to red. Haven't used that in a while. Let's see if we can squeeze something in here. So I'm done with 9A, but I can still do 9B. And in 9B, I know that A equals 30 degrees. Well, maybe I'll just pick which form of this I want to use. I have the angle A equals 30 degrees, so I'd want to use this second one here. I want to know that B squared, which is 16, plus C squared, which is 25, minus 2 times B times C, which is 40, times the cosine of A, I'm using this version here, cosine of 30 degrees has got to be equal to A squared. So A is equal to this plus this minus this square root. A is equal to the square root of, should I write that out? No, I think you can follow that. The square root of 16 plus 25 minus 40 times the cosine of 30. So if I figure out what this number is on the left-hand side of my equation and then take the square root, what I get is that A is about 2.5 something, which we call it 2.52. I don't really care about rounding. You can round these however the hell you want. But now that we know A, we can figure out the things we don't know. We know all three sides and we know one angle, so to figure out the other two angles, let's see, we could figure out B in a few different ways. I think the law of sines would probably be the easiest. We know that the sine of B divided by B is equal to the sine of A, which is 30 degrees, divided by A, which is this 2.52 thing that I just came up with. So in other words, if I do 4 times the sine of 30 degrees, and then I divide that by this 2.52 thing that I just came up with, what I get is that the sine of B, might just be able to squeeze this in after all, is equal to 0.793. So B is the arc sine of that thing. If you hit second sine to get arc sine, answer, what you get is 52.5-ish. And so finally, to figure out the last thing we don't know, what do we know? We know angle A and angle B. To figure out angle C, we know that angle A, which is 30 degrees, plus angle B, which is this 52.5 thing, plus angle C has to be equal to 180. So angle C is equal to 180 minus that answer we just came up with, minus 30 degrees. And what we get is C is 97.5. Wow, that was a lot of work. But you're finally done. We've solved all angles and all sides of both triangles for 9A and 9B. I should label it, this is 9B in here. So that's finally the end of this perfect problem.